All right, so there's our dip. So what are our two acronyms and errors that happen because of our dip?
Acceleration errors and turning errors.
Unos and.
Ands and unos. Unos, what would it be if you lived in Australia?
Opposite.
Assomes.
Okay, it would be opposite. Excuse me. Ands, accelerate north, decelerate south, happens, we see the main error when? When you're on an east or west heading. Okay, does it happen at other headings?
Sure.
It does. Next time you take off, watch your compass, see what happens. It turns north on your takeoff roll. That's an extreme acceleration, so it really turns. Okay. But on an east-west heading, that's going to be more pronounced. Okay. Unos. How much do we use here in Utah? 30 for north and south, right? Whoops. If I can get my compass right. Okay. What's the rule of thumb then? For how many degrees I'm supposed to undershoot and overshoot?
It's supposed to be north or south latitude, isn't it?
So it's approximately your latitude. Okay. What latitude are we at?
Approximately 41.
We're at 40, but 30 works here. Why?
Talk to your bank.
Nate Orgill, give him credit, figured this out. He goes, oh, it makes sense. Well, we don't just like snap roll out of things, we gradually roll out. Whenever we make a turn, you're supposed to lead off a turn by what? Half the bank angle. In steep turns we teach that, it works in normal turns. So always lead out your turn by half the bank angle. If I'm doing a 20-degree bank, I need to lead it by about 10 degrees before my actual heading. Hence, here, 30 works just great, even though we're at 40. So I would dare say, I haven't tried it yet, but I would dare say if you undershot by 40 and snap rolled it, it would probably work just as good. Unfortunately, IFR flying is not about snap rolling. So, 30, what's east and west? 0, okay? Then it goes up from there. So 060030 would be 10, 20. Oh, wait, I can't write today at all. 10 and 20. So 0, 10, 20, 30, 20, 10, 0, 10, 20, 30, 20, 10, 0. Okay, very easy, just something you have to remember. Now when we look at a compass, what we teach the students to do is to categorize the compass. We don't want them thinking about this while they're in the cockpit. Now one of the big things they get confused numerically. Undershoot by 30. Well, what heading should I roll out on then? It depends on which way I'm coming. So I could roll out on 03 or I could roll out on 330 depending on which direction I'm coming from. A lot of students think it's numerical. And so they start saying, oh, well, it's 330. Well, it could be different, okay? So that's the first misunderstanding that happens. The next one is, if you're using a compass turn, what kind of situation are you in?
Emergency, probably.
An emergency or a check ride. Either situation, you're nervous. So do you have time to sit there and try to think about math and, this, that? Doesn't work, okay? So what we've done is we've tried to come up with very easy methods to use, just like we do when we train emergency procedures. You come up with easier methods, okay? So when you look at a compass, you've got your window and then your little compass is inside, right? You can only see usually about 3 numbers at a time, okay? So when you see the compass, if I put this back in its case, you can really only see about 3 numbers at a time. So what we do is we teach them to categorize, okay? So in this situation, I've got east, 6, 3. Being able to look at the compass very quickly and just say, well, I know east is 0, right? 0, 10, 20. Well, what if I was supposed to turn in between right here at like 0, 4, 5? 0, 10, 15. I can fly a compass within 5 degrees. Okay? Very, very quickly, though, they do it. So the rule is, I tell you to turn to a heading of 1, 2, 0. Can you see it? Then we start our turn. And we don't really think about anything. We just start our turn. The worst thing that happens to students is they start thinking about it. When I first started doing stage checks, we were out doing an end-of-course check. And we were doing a partial panel or whatever, and I gave him a heading. And we flew for like 3 miles before he finally decided to start turning. Do that with ATC, they're not so friendly with you. Okay, so what it was is it was a lack of being able to know what to do. Well, I can't see it, so I just start turning. Left or right hand turn?
Right.
Right hand turn, compass is backwards. So I start doing a right hand turn, and as the compass starts rotating around, 120 is going to appear. Well, guess what? It's right next to east. How much is that? 10. So as soon as I can see it, I very quickly categorize, all right, 0, 10, that's a south heading, I'm going to overshoot it by 10 degrees. How much is 10 degrees? One big line. No numbers, no math. As soon as they start doing the math again, they totally mess it up and they come to the wrong side of the number because the compass is printed backwards. That's what screws everyone up. I had one student, anybody know Bob Duclos?
I know Bob. Me and Bob were old schoolmates.
There you go. Extremely smart with math. This kid would sit there and hand do E6B problems. He'd be like, oh, do you know why that works? And he'd like hand write out why the E6B works. And I'm like, I don't care. But he could do that. So he thought he could do this. He couldn't. He screwed it up like every time. Finally, after about 3 weeks of fighting with him, he decided that my method worked pretty dang good. Okay? So here's where we take it. We're trying to simplify it. Okay? Dummy it down. Originally, I came up with a lot of these procedures because I had hard students. And then I realized it's not a cheating procedure. It's just simply something easier to remember. Okay? So you've got your big line, your little line, your big line, your little line, your big line. Okay? So if I've got to overshoot by 20, it's 2 big lines. I'm just going to go past it by 2 big lines. I don't care what the number is. Once they start thinking numbers, that's where they start getting confused. Any questions on that? Okay? Let's talk about it really quick. Let's explain it a little bit more. Here's my awesome Coke compass. You can tell it's well used. If you're reading north, where's the north-seeking side of the compass? On the other side. That's what the black line on top represents, is the north-seeking side. That's what we're dealing with in the northern hemisphere. Okay? So, what happens is that whenever you go into a bank, that north-seeking side wants to point to the north. Well, if you think about it, I'm pointing at that door right now, okay? But if I tilt now, uh-oh, north's down there now. And so the compass literally starts falling. That's what causes our acceleration and our UNO's errors, is that it literally will start dipping, okay? So if you guys are on an east heading right now, so we'll put you on an east heading. You're going to make a left-hand turn to go north. So you bank into a left-hand turn. Where did I just point that? Down. Does it want to point down? It does. So what happens? It kind of gets stuck down there, and we have to undershoot north. Well, let's do the opposite. We're going to make a right-hand turn. So you guys all bank to the right. Where did I just point it? Does it want to point up? So as it starts rolling over, what happens? It goes faster because it starts slicing down through. You got to remember that a compass is designed to measure the horizontal plane. When I go into a bank, how am I supposed to measure the horizontal plane when I'm rotating like this? A little bit hard. North's not up there and south's not really down there, so where does it go? That's why we start getting our dips. Questions so far? Same thing on your accelerate, decelerate. You're on a west, you're on an east heading, sorry. You accelerate. What do all your heads do if you accelerated right now? Everybody's head goes back, right? What does the compass do? It goes back with your head just like that. I just pointed my little thing up. It wants to point down and shows a turn to the north. I decelerate. Oh, I just pointed it up again. It wants to point down. Shows a turn to the south. Okay? Now the problem is that the book talks about the weight on the compass. Okay? And that the weight causes the acceleration and deceleration errors. I'm not going to discount that maybe it contributes to it. The problem with teaching about the weight is that the weight works completely opposite of UNO's. So even mentioning the weight to me is kind of frivolous, because if the weight really has that much effect, we should, anyway, I'm not going to go into that. So when you read about the weight, great, it's probably there, balances the compass. That's why there's northern hemisphere and southern hemisphere compasses that you can buy, because the weight's on a different side of the compass to balance it, okay? To try to help out with the dip.